Okay, yeah, morning, folks. This time around, I'm moving on CIE Form 1 Mathematics. And please, this channel is going to be unveiling all the concepts that Form 1 classes might find interesting. This is one activity that for this year, if we can navigate truly, it means up to this month we in, that's February. I think we should have covered all those concepts enlisted, like prime numbers, number line, rational numbers, directed numbers, factors and multiples, divisibility rules, HCF, LCM, listing factors, mixed problems, estimating square roots, perfect squares, square roots, cubes, and cube roots. I hope this session will be interesting to you. And whenever you have got a query or somewhere where you want addressed, please don't hesitate. You can just comment on the section below. So this time around, I'm just going to quick go through the solutions which were expected in this activity. So let me pick my pen. I hope my pen writes. Right is writing. Check all the prime numbers below. And prime numbers, we know they run from 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. They go on like that. And when we say prime, it means it's a number divisible by 1 in this cell. So I'm circling. So this one happens to be a prime. And this one again is a prime. This one is a prime. This one is a prime. Wow, we spoke about 17. And we also spoke about 23. So those were the 5 primes that we were interested in. Write down the definition of a rational number. Rational number is a number represented in the form P divided by Q. Well, P and Q have to be integers, but we are saying because we are not allowed to divide by 0, so Q cannot be 0. Then we are moving to the next. Write the definition of directed numbers. So directed numbers, these are numbers which carry a sign. So we can say or positive and negative numbers. Or they can be real, can be all, but we are saying they are directed. So let me put numbers here. We are moving to the next. Plot the integers -5, -1, 0, 3, and 6 on the number line below. So if I'm to look, oh, we're supposed to have a proper number line, but it looks like ours is misaligned. So then I can circle that this is -5, this is -1. I've got my 0 here, I've got my 3 here, and my 6. I think that's all we needed from that problem. Still moving. Apply the divisibility to determine whether the number 324 is divisible by, well, we're given a number there. So we are applying divisibility rules for 2. Well, if a number is divisible by 2, it means the last figure should be even. So here we can say true. What's the reason? Last, well, I can put it here that last digit is even. Then for the second one, 3. Well, if we are testing divisibility by 3, we sum up the figures. So when we sum, let me do it separately, that 3 plus 2 plus 4 gives us a 9. 9 is a multiple of 3, so it means it's divisible by 3 because it's a multiple of 3. Now, last one I think it was 9. So we know 9 again is a multiple of 9. Hence, it's going to be divisible. Right. We try and scroll up and check where we left. So we were saying because 9 is a multiple of 9, then it means it's divisible. Now, the next one is saying list all the factors of 36. The first factor is always going to be 1. And I don't know how you do it because the moment you have a factor, you divide it by the figure you're given. So if I say 36 divided by 1, it means 36 somewhere is going to be a factor. But let me go to the next one because 36 is even. So it's divisible by 2. Even by 3, well, even by 4. And then I think 6 comes in. And then we also have 9, 12, 18, and 36 itself. But a feeling that's all the factors that we would need for 36. Those space for working. Now, find the HCF of 24 and 40. So HCF, that's highest common factors. Now, the method that we use is prime factorization. I can do it here that I've got 24. And I divide it by 2, it gives me 12. I divide it by 2, it gives me 6. I divide it by 2, it gives me 3. I divide by 3, it gives me 1. So I'll stop on 1 because I'm doing prime factorization. When I go to 40, 40 is there. If I divide 40 by 2, I get 20. I divide 20 by 2, I get 10. I divide 10 by 2, I get 5. Or I divide 5 by 5, I get 1. Now, this is what I'll do. I'll write these figures in exponential form. So where they are saying my working, I'm going to say 2 to the power 3 multiplied by 3. I know that's what gives me 24. I do the same for the 1. So 2 to the power 3 multiplied by 5. Now, what do we do on HCF? We check what's common. So what's common is 2. And when we look at 2, we look for the minimal power. So when we check is 3 and 3, so the minimal power is 3, which will give us 8. So it means the HCF of 24 and 40 is just 8. Moving to the next figure to say, can I find the LCM? What's LCM? Lowest common multiple of two numbers, 12 and 18. What's the smallest number? The smallest number divisible by those two given. So I'll still do the same process, which is prime factorization. I've got my 12 here, divided by 2 gives me 6, divided by 2 gives me 3, divided by 3 gives me 1. I stop at 1 because 1 is only a prime number. I do the same for 18. 18 is here, divided by 2, it gives me 9. I divide by 3, it gives me 3. I divide by 3, it gives me 1. So if I'm to write it in exponential form, for the first one, I've got 2 to the power 2 multiplied by 3. Then for the second one, I've got 2 multiplied by 3 squared. Now, with LCM, we will take from the common factors. We are going to take the highest exponent of all the factors we have. I can see that 2 is common, so the highest factor there is 2. So, the highest exponent is 2. So it's 2 to the power 2 multiplied by, when I compare the 3, there is a 1, there is a 2. So it's 3 to the power 2. And when I simplify, 2 to the power 2, that's 4. And 3 to the power 2, that's 9. 9 times 4, that's 36. So it means our LCM is 36. I'm now on number 9. A school schedule 2 activities, a music lesson every 6 days and a computer lesson every 8 days. If it both happen today, after how many days will they happen together again? So it's as good as I'm looking for LCM of 6 and 8. 6 and 8. So I'll do prime factorization here. I've got a 6. So if I divide it by 2, it gives me 3. I divide it by 3, it gives me 1. That's 6. Then I do it the same for 8. If I divide it by 2, it gives me 4. I divide it by 2, it gives me 2. I divide it by 2, it gives me 1. So if I'm to enlist, I've got 2 multiplied by 3. And for the second one, I've got 2 to the power 3. Now, if I want LCM, we said we'll take the highest power from all the prime factors we have. So I've got 2, which is common. So it'll be 2 to the power 3 multiplied by, remember 3 is alone, so that's the highest power. So multiplied by 3. So I have, in essence, 8 multiplied by 3. So it means my LCM is going to be 24. Still moving, estimate square root of 45 to nearest whole number. Now, what I'll do is, if I want square root of 45 to nearest whole number, I'm going to try and check for the perfect squares closer to 45. One thing that I know is if I take 6 squared, it gives me 36. If I take 7 squared, it gives me 49. I've got 45. So I might look at the difference between 36 and 45. So 36 and 45, it looks like they differ by 9. But if I look at the difference between 49 and 45, it's 4. So approximately, I'll use this lamb wavering. It looks like square root of 49 is closer to 7 than is to 6. So they are saying to the nearest whole number. So I can say it's actually equal to 7. Write the first 5 perfect squares. First 5 perfect squares, they come from natural numbers. When I say natural numbers, I'm talking about 1, 2, 3, 4, 5. Then the question is, can I square all these? And when I square, I'm interested in the result. I square 1, I'll get 1. I square 2, I get 4. I square 3, I get 9. I square 4, I get 16. I square 5, I get 25. Now, the last question I assume, find the cube root of 27. We're saying which number can you multiply by itself thrice to give you 27? That number should be 3. Which number can you multiply by itself thrice to give 125? That number should be 5. So that was the first activity, I assume, because it was out of 30 marks, and I hope you found it interesting. And whenever you have any queries or any section that you feel I need to expand on, please don't hesitate to, comment on the section below to say, perhaps this is an area of interest. Can you explain it in a different way? We can always do that. Thank you.